in this position, there is a connection or a closed switch on this side. Other position shows open. Okay? So let's see what happens with the two terminals on this side. Right now we have OL, there is no connection between the two. We'll flip our switch, and now we have resistance here. So really what we're seeing here is when the switch is in the up position, as you see it, there is a connection both between these two terminals and these two terminals simultaneously with the switch in this position. With the switch in this position towards you, there is no connection between anything at all. So it's indicating only when the switch is in this position do we have a connection from each one of these points to these ones here. All right, let's try one more connection. Let's go diagonally to here. In this position here, we have no connection. And let's try the opposite. Between here and here, we also have no connection and open. But let's flip the switch, and now you will see that there is a connection diagonally between the red terminal, the red lead and the black lead. So right now there is a closed connection this way. And let's just check, going back to the other diagonal, there is a connection here. Okay, so we have a connection diagonally this way. I haven't moved the switch yet. And we have also a connection this way here. When I flip the switch in the other position, now I do not have a connection here. My connection is either on this side without moving my switch. I also have that same connection on this side. When I flip the switch to this position, I either have a connection between these two terminals diagonally, or I have a connection diagonally between these two terminals. All right, so I'm just gonna pluck these guys out. So really what I'm seeing is with the switch in one position, my connections are closed here, and with the switch in the other position, my connection is closed here diagonally and closed between these two terminals diagonally. This is a representation of what's referred to as a four-way switch, and you should be able to draw that. When we have connections, closed connection in this direction, everything else is open. We flip the switch. Now there's connection is closed from here to here and from here to here simultaneously, and every other terminal connection is open. There is no connection here, 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 or here. This is the only connection. This is a representation of a four-way switch. Okay, perfect. Well, I have a different switch now, referred to as a 404, and as you will notice, it has the same terminal connection. What you see in the 403, it looks identical. So you would think this one should have the same connections as this one here. Well, let's just verify that by taking our leads, and the switch is in that position there. We'll start with this side here. We have no connection, so that is an open. I'm going to leave the switch position where it is. Let's go to this side. We also have no connection whatsoever there. Let's try the two leads on the towards you there. Nothing there, that's an open. And if we look at this side here, we still have OL, which indicates an open. All right, well, let's go back to our original connections here, and let's flip our switch at this point. So now when I change switch position from this to this, you'll see on your meter now we see an actual connection at this point here. Well, let's see what we have at this time here. There is a connection, a closed connection here. Do we have a connection here? There is no connection diagonally. We indicated already that there is no connection there. Let's try moving this to this side. Well, we do see that there is a connection here while we have a connection here. So really simultaneous, and let's just turn the switch to the other position. This becomes open, this becomes closed. Let's try this side again. This is closed, the other side is open. All right, so what this is indicating here, even though we have the 4 terminals, the yellow terminals like we did before, when our switch is in this position, there is no connection whatsoever between any of these terminals. When the switch is flipped to the other position, what happens is we only have connection between these 2 points. There is no diagonal connection whatsoever. So this would be a representation of a 2-pole switch, where typically from these leads to these leads, either we are in an open switch, and then when we flick the switch to the other position, we make connection from these 2 points to these 2 points simultaneous, and that is our closed connection. That is a representation of a 2-pole switch. That would be open and that would be closed. This would be referred to as a 2-pole switch. So it's important to indicate that we still have the same number of yellow terminals like we did the previous switch, but this is a totally different connection here that we have. All right. Okay, let's go on to a different type of device. This device here, it's referred to as a 178, and we have a bunch of different connections here. I know that the green connection is a ground connection, so we're not going to be using that. And let's see what happens with just our blue terminals. Okay, so just looking at our blue terminals, and we're going to plug our meter into both of those. Without touching our button here, we see that there is no connection. When we depress the button here, push it down, now we have a connection between the 2 blue points. Letting go, there is a spring action that releases the switch back to its original position, and we see that there is an open. So in this case here, we have what's referred to as a momentary switch. It is spring loaded, so there's a spring that pushes back up. In this position, there is an open between these two. When we push a force onto the switch, we make a different connection. Now the switch is closed between these 2 terminals. Okay, this is what you would notice in a momentary switch, that it reverts back to its original position. Let's see what happens on the 2 red terminals here. Now, not touching this the black button at all, we see that there is a connection between the 2 red points, and when I press the button, now there is an open between the 2 red points. Okay, and that would indicate when I let go that we have a connection finally between those 2 points. All right, so what we actually see, I'm going to go back to the blue terminals here. This would be an indication of a normally open push button. So normally when I'm not acting upon it, there is no connection. This is open. It is only when I put a force on it that it becomes a closed switch, that there is a connection between the 2 blues. Okay, so that is a normally open push button. Go back to the 2 red terminals over here. You'll notice that with no force acting upon it, we have a normally closed push button. We have connection between the 2 reds. It is only when I put a force on the button, push down on it, that the normally closed becomes open. All right, and that's the functionality of this switch here. On this side, this is normally open. When we push down on it, there's a connection, becomes closed. On this side, the two reds are normally closed. When I push on it, it does the opposite effect, becomes open. Sorry, there we go. So that's that switch there. We have what looks like a start button in green and a stop button in red, and this is a 177. We're going to see how these switches function. These two terminals are for the red, these two are for the start. So when I go to the start button, make a connection here, you see that it is open, that there is no connection. So we can say that this switch is normally open, and when we put a force on the button and push down on it, we see that now there is a connection there. So our normally open just became closed, a closed switch, and when we release, the spring pushes the switch, the push button back to its original position, being normally open. Our normally open push button becomes closed when there is a force on it. Okay, that's that start button there. Let's go over to this side here. You'll notice without any force put on this stop button that we do have a connection, so this indicates that we have a closed switch. This is a normally closed push button. We have a connection between